Okay, so in this lesson, we're going to be describing Earth's atmosphere, or learning how to describe Earth's atmosphere. In the photo that's right here, you can see that it appears as if Earth's atmosphere ends in a certain position or a certain place. It makes it appears that way, the photo does anyway, and that there's a set boundary between Earth's atmosphere and outer space. However, this is not the case. Earth's atmosphere does not end at a set altitude. Instead, it grows progressively thinner the farther you travel from Earth's surface. So let's take a look at the inquiry question. Why is the atmosphere important? Well, that one, I think a lot of us know that. I think most of you should know that information. But let's talk about it. What would Earth be like without its atmosphere? Earth's surface would be scarred with craters and created from the impact of those meteorites that would hit it. Earth would experience extreme daytime to nighttime temperature changes, unlike what we experience here, where it's a mild or gradual change. It would be very large temperature changes between night and day. How would changes in the atmosphere affect life? Questions we need to think about in this lesson. What effect would atmospheric changes have on weather and climate? How would the weather and the climate change if the atmosphere wasn't there? Okay, so these are some things we're going to be talking about in this lesson. So in your science journal, as we do all of the time, there's a few things that you need to start writing down. Okay, we want to look at these key concepts and essential questions right here. So in your science journal, please write these questions down, and by the end of this lesson, you should be able to answer them. The first one, which is right here, is how did Earth's atmosphere form? Okay, how did Earth's atmosphere form? The second one, what is Earth's atmosphere made of? The third, what are the layers of the atmosphere? And the last one that's here, how do air pressure and temperature change as altitude increases? So those are the essential questions that we want you to write in your science journal. Go ahead and pause the video, write the questions down, and by the end of the lesson, you should be able to answer them. Okay, the next important part, as always, in the very beginning of these, is your vocabulary words. Okay? So you have 6 words: atmosphere, water vapor, troposphere, stratosphere, ozone layer, and ionosphere. Go ahead and pause the video, write these terms down in your science journal. Very, very important that when we come across these terms in the in our lesson here for our video, you're going to stop the video, you're going to write your definition for each one of those terms, please. Okay? This is not a race. Make sure you're taking time and doing the work correctly so that you get a very good grade on your science journal, because they will be checked. Alright, so next, let's go ahead and ask you some important questions about some of the information that's here. Okay, some of the information that's involved with the atmosphere and the picture that's right in front of you. Okay, from looking at the photo, about how thick do you think Earth's atmosphere is? You're going to write these in your science journal, that one there. You're going to answer the question the best of your ability at this point. Okay, the next one I want you to write down is this one. Do you think the atmosphere contains the same things throughout, or does it change as you move away from Earth's surface? Write that down, please. The next one is this one. What do you think causes the atmosphere to stay wrapped around Earth instead of floating off into space? This one we've talked about in the past. I'm hoping you sort of remember that information. So write these 3 questions down in your science journal and answer those questions. Remember to pause the video, write the information down, and then restart the video again. Okay? Okay, so now we're going to be talking about the importance of Earth's atmosphere. So please listen closely.
Importance of Earth's atmosphere. The photo on the previous page shows Earth's atmosphere as seen from space. How would you describe the atmosphere? The atmosphere is a thin layer of gases surrounding Earth. Earth's atmosphere is hundreds of kilometers high. However, when compared to Earth's size, it is about as thick as an apple's skin is to an apple. The atmosphere contains the oxygen, carbon dioxide, and water necessary for life on Earth. Earth's atmosphere also acts like insulation on a house. It helps keep temperatures on Earth within a range in which living organisms can survive. Without it, daytime temperatures would be extremely high and nighttime temperatures would be extremely low. The atmosphere helps protect living organisms from some of the sun's harmful rays. It also helps protect Earth's surface from being struck by meteors. Most meteors that fall toward Earth burn up before reaching Earth's surface. Friction with the atmosphere causes it to burn. Only the very largest meteors strike Earth.
Okay, so we talked atmosphere. So here's your definition right here. Let me see if I can make it a tad bit larger so that you can write it down. Move some things over. The atmosphere is a thin layer of gases surrounding Earth. Okay, so go ahead and write this definition right here. The atmosphere is a thin layer of gases surrounding Earth. Okay, so you have that definition. At this point, I'm going to make it a lot smaller. I'm going to put it down here, okay? And then I'm going to ask some questions. So, let's see. Let me do some of this. Do some of this. Do some of this. All right. Now, here we go. Okay, the questions I'm going to ask you at this point are these three. This one, and this one. Remember, you're writing them down in your science journal. Okay, and you're answering those questions. How is Earth's atmosphere like the insulation of a house? Okay, number 2 you'll notice is a check. A check. Why is Earth's atmosphere important to life on Earth? Alright, and the last one is this one. What do you think the moon's surface indicates about its atmosphere? So you're going to write those 3 questions down. You're going to answer those 3 questions. Okay, so you're going to pause the video and do that, and then you're going to move on. Okay, so the next part of the lesson we're going to talk about is origins of Earth's atmosphere. So please listen, pay attention, and take your notes.
Origins of Earth's atmosphere. Most scientists agree that when Earth formed, it was a ball of molten rock. As Earth slowly cooled, its outer surface hardened. Erupting volcanoes emitted hot gases from Earth's interior. These gases surrounded Earth, forming an atmosphere. Ancient Earth's atmosphere was thought to be water vapor with a little carbon dioxide, CO2, and nitrogen. Water vapor is water in its gaseous form. This ancient atmosphere did not have enough oxygen to support life as we know it. As Earth and its atmosphere cooled, the water vapor condensed into liquid. Rain fell and then evaporated from Earth's surface repeatedly for thousands of years. Eventually, water accumulated on Earth's surface, forming oceans. Most of the original carbon dioxide that dissolved in rain is in rocks on the ocean floor. Today, the atmosphere has more nitrogen than carbon dioxide. Earth's first organisms could undergo photosynthesis, which changed the atmosphere. Recall that photosynthesis uses light energy to produce sugar and oxygen from carbon dioxide and water. The organisms removed carbon dioxide from the atmosphere and released oxygen into it. Eventually, the levels of carbon dioxide and oxygen supported the development of other organisms.
Okay, so as I pointed out while the reading was going on, there is another definition that you need to write down, and that is water vapor. Water vapor, okay, is this definition right here. All right. Water vapor is water in gaseous form. Water in a gaseous form. Okay? So go ahead and write that information down. You do not have to write the information in reference to the ancient atmosphere. Okay? You do not have to write that. All right? So, maybe it might surprise you that Earth's atmosphere has not always been the same. Okay, so let me ask you a couple of questions that will kind of lead us to that direction. Okay? Let me find what I'm looking for here. Because of course I've hidden them now with all the other information that I've made small. Moving stuff around. Here we go. These are the 3 questions I want to ask you. How was early Earth's atmosphere different from today's Earth? Use the reading. Use your workbook pages if you have them. And let's try to answer that question. Okay, that's this one right here. Notice that the next one underneath of it is a reading check question. I'm sorry, take that back. It is a key concept question, which is very important for us to answer at least by the end of the lesson. Okay, so that question is, how did Earth's present atmosphere form? How did Earth's present atmosphere form? Okay, and the last question is this one right here. How might Earth's atmosphere be different today if there were no photosynthetic organisms? Okay? Basically what it's asking is photosynthesis that are produced by organisms. Okay? How might Earth's atmosphere be different if that didn't happen? So those 3 questions, please make sure you're pausing the information, writing the questions down, and answering them, please, to the best of your ability. All right? All right. Okay, so in this part of the lesson, we're going to talk about the composition of the atmosphere. Remember, composition means what it's made of. Okay, so we're going to talk about what the atmosphere is made of. So please listen.
Composition of the atmosphere. Today's atmosphere is mostly made up of invisible gases, including nitrogen, oxygen, and carbon dioxide. Some solid and liquid particles, such as ash from volcanic eruptions and water droplets, are also present. Gases in the atmosphere. Study Figure 1. Which gas is the most abundant in Earth's atmosphere? Nitrogen makes up about 78% of Earth's atmosphere. About 21% of Earth's atmosphere is oxygen. Other gases, including argon, carbon dioxide, and water vapor, make up the remaining 1% of the atmosphere. The amounts of water vapor, carbon dioxide, and ozone vary. The concentration of water vapor in the atmosphere ranges from 0 to 4%. Carbon dioxide is 0.038% of the atmosphere. A small amount of ozone is at high altitudes. Ozone also occurs near Earth's surface in urban areas.
Okay, so you notice the picture or the pie chart. Okay, let's go ahead and take a look here. Oxygen is 21% and nitrogen is 78%. But then you notice that there's this little piece of information right here. Okay? Those are considered the 1% that's other gases. That contains water vapor, argon, carbon dioxide, and ozone. And ozone, O3, is a gas. Okay? Ozone is a gas. So we're going to be talking a little bit more about that information. But I want to go ahead and slice that down a little bit. Move this over. And then I want to ask you a couple of questions. Okay? Write these questions down, please. Answering them as we go. List 6 gases found in the atmosphere. 6 gases found in the atmosphere. Okay, so the pie chart that I just showed you, this one here, could probably help you. So if you need to, go back, look at that chart, and see what we've got, okay? The next one is this question right here. What do you think might cause the amount of water vapor in the atmosphere to vary? Vary. V-A-R-E or V-A-R-Y. Vary. Or to change or not always be the same. Okay, that's what vary means. Okay, so what do you think might cause the amount of water vapor in the atmosphere to vary? Okay, alright, so I'm going to do this. Make sure you're writing those down and answering them. Closing that information up. I'm going to close this information up because I know we've already talked about it also. Okay, so the next part that we're going on to is solids and liquids in the atmosphere. So please pay attention, listen closely.
Solids and liquids in the atmosphere. Tiny solid particles are also in Earth's atmosphere. Many of these, such as pollen, dust, and salt, can enter the atmosphere through natural processes. Figure 2 shows another natural source of particles in the atmosphere: ash from volcanic eruptions. Some solid particles enter the atmosphere because of human activities, such as driving vehicles that exhaust soot. The most common liquid particles in the atmosphere are water droplets. Although microscopic in size, water droplets are visible when they form clouds. Other atmospheric liquids include acids that result when volcanoes erupt and fossil fuels are burned. Sulfur dioxide and nitrous oxide combine with water vapor in the air and form the acids.
Okay, so as you take a look at the picture that's right here, you see the volcano right here that is spewing ash into the air. That is the one way solid particles enter the atmosphere, is through volcanic eruptions. Okay, volcanic eruptions provide us with solid particles in the atmosphere. Alright, so closing that one down. And moving right along to our next question. This one here. Okay, next two questions you need to write in your science journal, please. This first one. What do you think would be some of the effects of an increase in solid particles in the atmosphere? All right, increase in solid particles. So if we had more volcanic eruptions, what would happen? Okay. Next, this one here, and notice again the key concept check question. What is Earth's atmosphere made of? What's it made of? You should be able to answer this one by now. Okay, so we will check it out when you get to class and we'll go through that information. Closing this information down. Make sure you're writing those. Pausing the video, of course. Going through the information. Okay, making sure you know all the information that you need to know. Okay, so the next thing we're going to talk about is layers of the atmosphere. Okay, this one's kind of important. It's kind of a big deal for us because it's the subject we're involved with at this point. Okay, move some stuff over because we need to take a look at this chart right here. Okay, so now, like I said, we're going to be talking about the layers of the atmosphere. So please listen. We'll go through them and then we'll talk a little bit about them.
Layers of the atmosphere. The atmosphere has several different layers as shown in Figure 3. Each layer has unique properties, including the composition of gases and how temperature changes with altitude. Notice that the scale between 0 to 100 kilometers in Figure 3 is not the same as the scale from 100 to 700 kilometers. This is so all the layers can be shown in one image. Troposphere. The atmospheric layer closest to Earth's surface is called the troposphere. Most people spend their entire lives within the troposphere. It extends from Earth's surface to altitudes between 8 to 15 kilometers. Its name comes from the Greek word tropos, which means change. The temperature in the troposphere decreases as you move away from Earth. The warmest part of the troposphere is near Earth's surface. This is because most sunlight passes through the atmosphere and warms Earth's surface. The warmth is radiated to the troposphere, causing weather.
Okay, so now this will be our definition. Let me make it so that we can see it, please. Troposphere. Okay, the troposphere is the atmospheric layer closest to Earth's surface, and it is called the troposphere. Okay, so next, what I want you to do is write that definition down, please. Okay, pause it, pause the video, write the definition down. It's kind of important that you have this one, and we will be having a vocab quiz over this information, so write troposphere down with its definition, please. Okay, now let's go back through this, moving it around. All right. So let me ask you a couple of questions. You do realize that the troposphere is the layer that we live in, so it is the layer that you probably know the most about. Okay? You probably know the most about the troposphere. So the couple of questions I want to ask you are these right here. How does the temperature change as you rise higher in the troposphere? Okay. That's that one right there. The last one is a reading check question there. Describe the troposphere. So tell me what the troposphere is like and what we can find in that, or what happens in that layer. Describe the troposphere. Okay, I also want to ask one other question. So let me make this smaller. Okay, and this one larger. And it's in reference to the information that we've just covered, which is the troposphere, which is right here on this chart. Okay, you'll notice the plane. Okay, this is where the clouds form. That is the layer of the troposphere. Okay, all the clouds in Figure 3 are shown in the troposphere. What can you infer from this? What can you infer from the clouds being in this layer? Okay, write that question down. Please answer it. Okay, so the next part of the information that we're going to talk about is the stratosphere. The stratosphere is this section right here. Okay, so please listen, pay close attention. Okay, and then we will talk a little further after this is done.
Stratosphere. The atmospheric layer directly above the troposphere is the stratosphere. The stratosphere extends from about 15 kilometers to about 50 kilometers above Earth's surface. The lower half of the stratosphere contains the greatest amount of ozone gas. The area of the stratosphere with a high concentration of ozone is referred to as the ozone layer. The presence of the ozone layer causes increasing stratospheric temperatures with increasing altitude. An ozone, O3 molecule, differs from an oxygen, O2 molecule. Ozone has 3 oxygen atoms instead of 2. This difference is important because ozone absorbs the sun's ultraviolet rays more effectively than oxygen does. Ozone protects Earth from ultraviolet rays that can kill plants, animals, and other organisms and cause skin cancer in humans.
Okay, so you need to remember that as we progress through this reading section, what we're talking about is a progression of higher layers of atmosphere. So we're going to start at the bottom, which is what we did with the troposphere, moving up to the stratosphere, and on, moving higher into the atmosphere. Okay? But in this one, there were 2 definitions I need you to know. Okay? 2 definitions I need you to know. One of them is this one right here. You're talking about the stratosphere. The atmospheric layer directly above the troposphere is the stratosphere. Please write that down in your science journal, making note that that is a vocabulary word, please. All right. The next one I want you to write down will be ozone. The ozone layer. The area of the stratosphere where a high concentration of ozone, that is referred to the ozone layer. Okay? Make sure you're writing that also down, please. Okay, so hope you got those written down so we can discuss those in class. Last thing I want to do, I'm going to move this over. Okay, and then I want to ask 3 more questions. Please write these 3 questions down. Okay, these are in reference to the stratosphere. What is the ozone layer? The first one is, what is the ozone layer? The second one, why is the stratosphere particularly important to life on Earth? Okay, this last one then, what might happen if the ozone layer began to thin? Write all 3 of those questions, this one, and this one, in your science journal. Answering those questions, please. All right, if you need to, make sure you're pausing and moving on as soon as you write all that information down. Okay, so now we're going to move on to the next 2 layers, which would be the mesosphere and the thermosphere. Okay, so please listen, and once we get finished with that, we'll talk about it. So listen carefully, please.
Mesosphere and thermosphere. As shown in Figure 3, the mesosphere extends from the stratosphere to about 85 kilometers above Earth. The thermosphere can extend from the mesosphere to more than 500 kilometers above Earth. Combined, these layers are much broader than the troposphere and the stratosphere, yet only 1% of the atmosphere's gas molecules are found in the mesosphere and the thermosphere. Most meteors burn up in these layers instead of striking Earth. The ionosphere. The ionosphere is a region within the mesosphere and thermosphere that contains ions. Between 60 kilometers and 500 kilometers above Earth's surface, the ionosphere's ions reflect AM radio waves transmitted at ground level. After sunset, when ions recombine, this reflection increases. Figure 4 shows how AM radio waves can travel long distances, especially at night, by bouncing off Earth and the ionosphere. Auroras. The ionosphere is where stunning displays of colored lights called auroras occur, as shown in Figure 5. Auroras are most frequent in the spring and fall, but are best seen when the winter skies are dark. Auroras occur when ions from the sun strike air molecules, causing them to emit vivid colors of light. People who live in the higher latitudes, nearer to the North Pole and the South Pole, are most likely to see auroras.
Okay, so I know you caught that one of those terms was ionosphere. An ionosphere, which is this one right here, is one of your vocabulary words. So let's go ahead and write your definition, please. The ionosphere is a region within the mesosphere and the thermosphere that contains ions. Okay, so write that definition, please, making sure that you have it so that you know it for your vocab quiz. All right, closing that part down. I'm going to ask a couple of questions here. Actually, I'm going to ask 3 questions, if you don't mind. Okay, moving some things around so that we can do that. Okay, so what I want to ask you are these 3 questions here. This one here. How do AM radio waves interact with ionosphere? Okay. The second one. How are the mesosphere and the thermosphere different from the troposphere and the stratosphere? So now we're getting into differences between the spheres, or the areas in the atmosphere. Okay. The last one is this one here. Why do you think meteors burn up as they travel through the mesosphere and the thermosphere? So those 3 questions, this one, and this one, please write down in your science journal. All right, making sure that you understand them and answering them, please. Okay, you may want to use this example for this one if you can do so. Okay? Okay, so the next information we're going to talk about is the exosphere. Exosphere. So please listen carefully, and we will be talking about it afterward.
Exosphere. The exosphere is the atmospheric layer farthest from Earth's surface. Here, pressure and density are so low that individual gas molecules rarely strike one another. The molecules move at incredibly fast speeds after absorbing the sun's radiation. Since there is no definite edge to the atmosphere, molecules can escape the pull of gravity and travel into space.
Okay, so from that information, you know that the exosphere is the layer that's the farthest away from Earth's surface. Okay? Pressure and density are so low that the gas molecules rarely strike each other because it's so much space. Okay, so next we're going to talk about air pressure and altitude. So let's bring up some additional information, closing off the information we don't need any longer. Okay, so let's make this a little larger so you can see it. We'll move this over to the side for right now. Okay, air pressure and altitude will be what we're talking about next, so please listen closely.
Air pressure and altitude. Gravity is the force that pulls all objects toward Earth. When you stand on a scale, you can read your weight. This is because gravity is pulling you toward Earth. Gravity also pulls the atmosphere toward Earth. The pressure that a column of air exerts on anything below it is called air pressure. Gravity's pull on air increases its density. At higher altitudes, the air is less dense. Figure 6 shows that air pressure is greatest near Earth's surface because the air molecules are closer together. This dense air exerts more force than the less dense air near the top of the atmosphere. Mountain climbers sometimes carry oxygen tanks at high altitudes because fewer oxygen molecules are in the air at high altitudes.
Okay, so as the picture shows, reading this information, molecules in the air are closer together near Earth's surface. Notice that right there, closer together. But as we increase in altitude or go higher in altitude, they spread out. They tend to spread out. Okay, you might not feel it, but every time a molecule of air bounces off your skin, it applies a small amount of force or pressure. Okay, so think about that. You don't feel it, but it actually does happen. All right, so let's move on to our questions here that I want to ask. Bringing those up. Okay, so first question is this one. Where would air pressure be the greatest? At sea level or on top of the mountain? Go ahead and write that question down, please. Pausing if you need to. I know we multitask a lot, but please don't multitask while you're doing this. Second question, this one right here, and notice it's a reading check question over the information we've talked about. How does air pressure change as altitude increases? Okay, the third one is this one right here. Why doesn't gravity pull all the particles in the atmosphere close to Earth's surface? Okay, so those three questions, this one, and this one, need to be written down in your science journal and answered, please. Okay, so the next information we're going to be talking about is temperature and altitude. So pay attention, please, and listen.
Temperature and altitude. Figure 7 shows how temperature changes with altitude in the different layers of the atmosphere. If you have ever been hiking in the mountains, you have experienced the temperature cooling as you hike to higher elevations. In the troposphere, temperature decreases as altitude increases. Notice that the opposite effect occurs in the stratosphere. As altitude increases, temperature increases. This is because of the high concentration of ozone in the stratosphere. Ozone absorbs energy from sunlight, which increases the temperature in the stratosphere. In the mesosphere, as altitude increases, temperature again decreases. In the thermosphere and exosphere, temperatures increase as altitude increases. These layers receive large amounts of energy from the sun. This energy is spread across a small number of particles, creating high temperatures.
Okay, so just as a little bit of an example, the chart that we have here actually is just an explanation or a visual of the information the text was giving you. You'll notice that I ran my my green arrow along the red line. The red line tells you where the temperature is heading. Notice that temperature is at the bottom. As we go from left to right, the temperature increases. As the altitude starts here, we go up in altitude. So you'll notice that the red line follows this direction to decrease, and then increase, then decreases, then up again to increase. So that is just a visual of the information that was just read to you. Now I do have sort of a question for you, and I will ask this in class, not one you have to not one you have to write down, but one that you have to think about. Okay? How does temperature change as altitude increases? Using this chart, the chart that I just read or looked at with you, you can use that information to try to answer that question, and I will have a copy of that chart so that you can look at it when we come to class. The other thing I want to ask you is, taking a look at all of this information here, which temperature pattern is most like the troposphere? The troposphere is here. Which one of those temperature patterns in one of these spheres is most like the troposphere? Alright, so I will be asking that one also. Okay, so with that information, we've now gone through all of the reading in the text. Okay, so the next step would be for you to complete the lesson review, which will be on the next frame. Okay, the lesson review is in front of you, and what you're going to be doing is you are going to be writing each one of these questions. Okay, writing the question, actually this one, all you're doing is copying this information. Okay, answering the question, writing the question and answering, please. Answer those questions to the best of your ability using the information that you have in front of you. Okay, you could have your workbook pages, you can have the reading notes that you just took, or you can play back and see if you can hear some of the information. Okay, I want them completed. It is part of the Science Journal grade. If it's not completed, then you're only going to get partial credit for the Science Journal, and if you're not completing the Science Journal at all with any of those questions, you're not getting any credit. Okay? We have a journal check every time we have a video. Please follow through, write down the information, and start to learn. All right? Hope you learned something in this lesson.